Good morning, everybody. Welcome to the Mahakal Raj YouTube channel. Today, we are here to discuss a topic of physical pharmaceutics. Second, and the first unit is colloidal dispersion. Colloidal dispersion can be described as by the heterogeneous system. It consists of dispersed phase and dispersed medium, in which particles of dispersed phase range from 1 nanometer to 1000 nanometer. Now we will discuss about dispersed medium and dispersed phase. In dispersed medium, that medium in which colloidal particles are dispersed, that is called dispersed medium. And in case of dispersed phase, that is scattered or present in form of colloidal particles is called dispersed phase. Now we will discuss about types of colloidal dispersion. Now it is of solid, liquid, gas. Now in case of solid, when we mix with solid in solid, it will get just like, for example, colloidal dispersion. And in case of liquid solid, when we mix in solid in liquid, then for example addition of sugar in water. And when we add solid in gas, for example NaCl. And now when we add in liquid in solid, for example toothpaste, and liquid in liquid, just with like milk plus water, and liquid in gas, fog, gas in solid, camphor, gas in liquid, cold drinks, and gas in gas environment, gases. Now we will discuss about classification of colloids. There are three types of colloids: lyophilic colloids, lyophobic colloids, and association colloids. Lyophilic colloids. Lyo means liquid and philic means loving. So we can define it as when dispersed phase and dispersed medium both interact to each other. Then it is called lyophilic colloids. It is also of two types: lipophilic and hydrophilic colloids. Lipophilic colloids, it can be defined as dispersion medium is non-aqueous. When dispersion medium is non-aqueous organic solvent, then they are called lipophilic. And in case of hydrophilic, dispersion medium is water, that is called hydrophilic medium. And another is lyophobic colloids. Lyo means liquid and phobic means hating. It means when dispersion medium and dispersion phase doesn't interact to each other, means they does not interact to each other, then it is called lyophobic colloids. And the third one is association colloids. Another name, amphiphilic colloids. Another name of association colloids is amphiphilic colloids. It will at low concentration, it amphiphils exist separately, and but at a high concentration, aggregation occur over a narrow concentration range. These aggregates are only called micelles. Now we will discuss about properties of colloids: optical properties, kinetic properties, electrical properties. And in case of optical properties, we will discuss there are four types: ultramicroscope, electron microscope, Tyndall effect, light scattering. And in case of kinetic properties, it is of five types: Brown motion, diffusion, osmotic pressure, sedimentation, viscosity. Electrical properties: electrophoresis, electric double layer, protective colloids, and gold number. Now we will discuss briefly optical properties. Optics means light, means when light is used in experiment, that is called optical properties. Now it is of ultramicroscope. When light is passed through solution of dark background, when we pass a light in solution in background, when background is dark, then particle will spread automatically and can be seen easily. Means when we take a dark brand and pass light through a solution, then uh, then particles will get automatically shine and can be observed easily. Second one is electron microscopy. This is used to observe size, shape and structure of colloidal particles. It means when in electron microscope we can observe size of colloidal particles, shape and what is their structure, and it can be ranged from 1 nanometer to 10 nanometer. And the third one is Tyndall effect. When beam of light is passed through a colloidal solution, then the path of light get illuminated. This is called Tyndall effect. As we know, when beam of light is passed through a colloidal solution, when we pass a light just like laser light from the solution, then path of it will get through the solution straight, and when wherever particle will come it will get distract, and from this we can check that particles we observed. And the fourth one is light scattering. It is used to get information on the shape and size of particles. Scattering can be described in terms of turbidity. In this shape and size we can get information about shape and size, and scattering can be described. And from this scattering also we described. Now the second property is kinetic property. Kinetic means motion. It means when motion is used in the experiment. In case of optical properties, light was used, but in case of kinetic property, motion is used in experiment. Now it is a Brownian motion, continuous collision between colloidal particles and molecules of dispersion medium. When colloidal particles and dispersion medium of molecules will collide to each other, then they form an energy that is called Brownian motion. Second one is diffusion. Transfer of particles from high concentration, it will become uniform. It means transfer of high particles from high concentration to the lower concentration. That process is called diffusion. And in case of osmotic pressure, third one, it is used to calculate molecules weight of colloid in dilute solution. In this we can calculate molecules weight of colloid in dilute solution. And the fourth one is sedimentation. Due to particle weight, particles settle down in solution, and this is called sedimentation. If sedimentation increase, then automatically stability decrease. It means when sedimentation process increases, then stability decreases, and if stability decreases, then sedimentation increases. And the fifth one is viscosity. It is resistance to fluid to flow under an applied force. Viscosity can be defined as the flow of fluid under an applied stress, just like in case of milk. Now the third property is electrical property. Electric means motion of electrons. When motion of electrons, it form an energy. Okay, and now its first part is electrophoresis. Movement of colloidal particles through a liquid under influence of electric field is called electrophoresis. It means when colloidal particles move through a liquid, they form an electric field. It means positive electron gets separated and negative electron get another separated. When we provide electric current, then colloidal particle migrate to opposite charge electrode. And when electric pass is passed through the solution, then the particles both will migrate to opposite to each other. But when electric current was not passed, they were mixed with each other. And the second part is electron double layer. When different charge formation of two layer on colloidal particles, then it is called double layer. It means when two different charge formation of two layer, it means different of colloidal particles, then it is called double layer. Third one is protective colloids. When large number of hydrophilic colloids carrying negative charge is combined with positive charge, then they form protective layer. It means when large amount of hydrophilic colloids carrying negative charge, hydrophilic colloids have negative charge, and when it will get combined with positive charge, then they form protective layer. Okay, just like when positive and negative charge both get intermixed to each other, then they form both protective layer. And the fourth one is gold number. It is defined as number of milligram of protective colloid required in 10 ml of red gold solution to prevent change in color from red to violet. It means when red to violet change color due to red gold solution, 10 ml of red gold solution to prevent change in color from red to violet. And the other, now we will start about how stability colloids stable. It means stability of colloids. Stability of colloid prevent them from aggregation. It means stability prevent them from aggregation. There are two mechanisms of colloid stabilization: steric stabilization and electrostatic stabilization. In case of steric stabilization, each particle is surrounded with solvent sheet to prevent adhere. Each particle is surrounded with solvent sheet to prevent adhere. And in case of electrostatic stabilization, in these particles are provided with electric charges. In electrostatic stabilization, particles are provided with electric charge. And now we will discuss about the effect of electrolyte. On lyophobic colloids, it is unstable. Diallo theory is used to discover stability of dispersion. According to this, distance between two colloidal particles affect the behavior of particle. Means when colloidal particles distance and their behavior of particle, it depend upon this. This theory is used to measure amount of electrolyte used to precipitate. And as we know, when energy get increased, repulsion also get increases, as shown in diagram. And when energy get decreased, then repulsion also get decreases. Intermediate distance also increases, and potential barrier also increases when energy increases. Now in this, it is primary minimum, as shown in figure. We will discuss here about primary minimum. When particles are close to each other and form strong bond, due to this there is rapid increase in potential energy. It means when particles are close to each other, when they are very close and form strong bond, and due to this there is rapid and when increase in potential energy increases and particles get closer and strong bond, then it is called primary minimum. And secondary minimum. Now, as you know, when two electrons holes and the dialysis, they form coagulation, settle down at bottom, and form electrolytes. Now, second one is secondary minimum. It is totally opposite to primary minimum. It means it work opposite to primary minimum. These are thermodynamically stable, but particle undergo aggregation, coagulation, or precipitation. These are thermodynamically stable, but particles undergo aggregation, coagulation, or precipitation because when electrolytes are added in higher concentration, hydration of particles is observed. It means when we add electrolytes in higher concentration, then hydration of particles get observed. And in case of second addition, when we add non-solvent as alcohol to hydrophilic colloids cause dehydration of particles. When small amount of electrolytes are added, it causes flocculation. When we add that small amount of electrolytes, then it is called flocculation. This is called secondary minimum. And now we will discuss about coercion. When two opposite charged hydrophilic colloids are mixed, when two opposite are just like positive and negative charge hydro are charged, when then hydrophilic colloids are mixed, then there will be a separation of colloids are mixed. Means there colloids which are separated, they will get mixed automatically, and then there will be a separation of colloid rich layer. Then it will separation of colloid rich layer. The colloid rich layer is known as conservate. This is called conservation. For example, gelatin. In case of gelatin, two positors are mixed, and separation of colloids are mixed, and separation of colloid rich layer gets separated. This is called concentrate. For example, gelatin. Thank you. Don't. And now we will discuss about peptidation. It is process in which aggregates are break into colloidal sized particles in presence of peptidizing agent. It may be liquid, electrolytes, and non-electrolytes. And when we add electrolytes to a freshly precipitated substance, particle adsorb one particular type of ions of electrolyte get dispersed due to electrostatic repulsion. Thank you everyone, and don't forget to subscribe, share, and comment. Please give your feedback. Thank you very much. Bye and have a nice day.